So write down the next problem. Question number 31. An object moving with a speed of 6.25 meter per second, 6.25 meter per second, comma, is retarded at a rate given by dvdt equal to minus 2.5, dvdt equal to minus 2.5 into root v, 2.5 into root v, where v is the instantaneous speed. Full stop. The time taken by the object to come to rest will be, time taken by the object to come to rest will be option A 2 seconds, option B 4 seconds, option C 8 seconds, option D 1 second. Option A. 2 seconds. Four second. Option D. Option 1. Correct.
Option D.
Option A. 2 seconds. How you solve? Wrong. Answer is option A. 2 seconds. You cannot use V equal to U plus AT to solve the problem, because that equation is valid for constant acceleration or constant retardation. Here acceleration or retardation is a variable. It depends on root V. dv dt equal to minus 2.5 root V means acceleration is variable. So in case of variable acceleration, you cannot use V equal to U plus AT, because those 3 or 4 equations in kinematics are valid for only constant acceleration along a straight line. Okay, so this problem requires the integration, otherwise you cannot solve this problem, because this is a variable acceleration problem. Okay, so it is given here that dv dt equal to minus 2.5 root v. So from this you can write it is dv by root v equal to minus 2.5 dt. Now this can be written as v to the power minus half dv equal to minus 2.5 dt. 0 to t means within how much time velocity will become 0, that I have to find out. So initial time is 0, final time is considered as t after some time. Or you can also or here is velocity is changing. Initial velocity 6.25, final velocity 0, because it is asked that after how long the particle will come to rest. So final velocity will be 0 after a certain time t. Clear? So this integration you have to perform. So its integration will be v to the power minus half plus 1 by minus half plus 1. So minus half plus 1 means v to the power half. So it will be v to the power half by half. Limit is from 6.25 to 0, and this one will be minus 2.5 into t. Integration of dt will be t, upper limit t, lower limit 0, so it will be minus 2.5 t. Okay. Now calculate. So if you put the upper limit in this case, so it will be 0, then minus of 6.25 to the power half divided by half. So this half can be multiplied as 2 here, it will be minus 2.5 into t. Now simplify and find. So 6.25 square root, it will become 2 into 2.5, 2.5 t. So t will become 2 seconds. Okay. So what we have to do first, when this expression is given in the problem, identify that this term is acceleration, minus sign because it is slowing down, that is called retardation. Now this term represents the variable quantity, that is instantaneous velocity in this case. Otherwise, if this dv dt is constant, then we can easily use the equation of kinematics that we have learned already for motion along a straight line with constant acceleration. But here we cannot use that because of the presence of this term. This term makes the acceleration term variable. Okay. Now since it is variable, then we have to integrate. So just write separating the variable, then start integrating. It is said that after how much time the particle comes to stop. So initial limit of time will be starting point, that is t equal to 0. Final time will be some later time which is denoted by t. You can also denote it by any other symbol, capital T or anything. Similarly, v initially it is given 6.25, finally comes to rest means final velocity will become 0. And then solve the integration and you will get the result. Okay. Okay. Next question, question number 33. A particle moves a distance x in time t. A particle moves a distance x in time t according to the relation x equal to t plus 5 whole to the power minus 1, means x equal to t plus 5 under bracket whole to the power minus 1. The acceleration of the particle is proportional to, this is like this, x equal to t plus 5 to the power minus 1. Acceleration of the particle is proportional to, option A, velocity is to the power 3 by 2, means instantaneous velocity to the power 3 by 2. Option B, distance square. Option C, distance to the power minus 2. Option D, velocity to the power 2 by 3. Option A, velocity to the power 3 by 2. Option B, distance to the power 2. Option C, distance to the power minus 2. Option D, velocity to the power 2 by 3.
to the power 3 by 2.
Option D and A. x is given in terms of t. First calculate dx dt to find instantaneous velocity. And after that calculate dv dt to find acceleration. So you will get velocity in terms of time, acceleration in terms of time, then try to eliminate time to get the relation. Because three equations now you have. One is x in terms of time, one is velocity in terms of time, one is acceleration in terms of time. Then eliminate time to find acceleration in terms of velocity and distance and check which one is correct option. This one is x equal to t. So from x equal to t plus 5 whole to the power minus 1. So first calculate v. V means dx dt. So if you calculate derivative, differentiate this one with respect to t, it will be minus 1 t plus 5 to the power minus 2, and derivative of the inside term is 1. So due to chain rule it will be multiplied by 1. So nothing else, it will remain same. Now calculate acceleration from this. So this power will come in front of this nx to the power n minus 1. So it will be minus 2 into minus 1, that is plus 2, and this term will be t plus 5 whole to the power minus 3. Okay. Now from this try to eliminate and write a in terms of x. Just check what is t plus 5 to the power minus 1, that is x. So I can write this term to be 2 into x to the power 3, because t plus 5 whole to the power minus 1 means x. So this term is t plus 5 whole to the power minus 3. So I can consider this one is t plus 5 whole to the power minus 1 whole to the power 3. So I put t plus 5 whole to the power minus 1 as x, then it will be x to the power 3. Is the relation matching? No. Then calculate this one a and v. Eliminate t plus 5 from these two equations to find a relation between a and v. Calculate. How to calculate it? Take a square of this equation. Okay, so a square will become 4 t plus 5 whole to the power minus 6, and take a cube of this equation. V cube equal to minus t plus 5 whole to the power. Now you can eliminate a square by v cube, that is coming minus 4. Sorry, a square by v cube. So a square is proportional to V cube. So I can write A is proportional to 3 by 2. A square by V cube is coming constant. So A square proportional to V cube means A is proportional to V to the power 3 by 2. Okay. The first relation is given x as a function of time. You have to find v as a function of time and a as a function of time. Then you have to eliminate time to find a as a function of x and as a function of v, and then check which option is matching.
So last option is V 2 by 3. So we've got V 2 by 3.
So first option is correct. Okay. Write down question number 35. Two cars P and Q. Two cars P and Q start from a point at same time. Starts from a point at same time in a straight line. And their positions are represented by at what time do the cars have the same velocity? These are the options. A minus f by 1 plus b, a plus f by 2 into b minus 1, a plus f by 2 into 1 plus b, f minus a by 2 into 1 plus b. Option? Last option? Maybe. Solve. Come here and solve. It is one of the mock papers question. Correct. Good. So one by one, I will call one of you to solve any problem. This is a good method. And after one session, you will give me the name of that virus. Okay, write down. Next problem. Achha, all these problem that we solved from the yesterday's class, mark it as part 1, problem set part 1. Okay, now problem set part 2, again non kinematics problem, another problem set is there. Question number 2, problem set part 2, question number 2. A body is thrown vertically upward. A body is thrown vertically upward in air. When air resistance is taken into account, when air resistance is taken into account, the time of ascent is T1. The time of ascent is T1 and the time of descent is T2. Time of ascent T1, time of descent T2, comma, then which of the following is true? Option A, T1 equal to T2. Option B, T1 less than T2. Option C, T1 greater than T2. Option D, T1 greater than equal to T2. C. Why? Just think about the situation. When it is moving up in air resistance, in the presence of air resistance, acceleration due to gravity is downward. So pulling it down means as a retardation. Moreover, the air resistance is also downward because it is moving up. Air resistance is opposite to velocity, that is viscous force. So both are moving downward. So the downward retardation will increase when it is moving up. When it is falling down from the top, it reaches the maximum height and then again falling from the top. Now what happens? The gravity is downward, but the air resistance is upward. So now the effective acceleration is g minus a. Previously it is g plus a. Now it is g minus a. So in which case acceleration is larger? In the first case. So acceleration, it is not the acceleration, it is the retardation. Retardation larger means it will take more time. Okay. So from this argument many students can answer this one. But I will remind you, when you are throwing this, you are projecting it with a certain velocity. But when after reaching to the top it will fall, its velocity, initial velocity will become 0. So can't that change the answer? That you are supplying velocity and second time you are not supplying any velocity. So on the first logic, if you say that time of ascent is greater than time of descent, then a cross question can arise that whenever it is ascending, you are supplying it with a certain initial velocity. But when it is falling, no additional velocity is supplied. So still your answer remains the first one based on the first logic or not? If you forget about the initial velocity, then you can say that okay, for my first logic is correct and T1 is greater than T2. But if I ask you the second point, that you are supplying some additional velocity when it is moving up and not supplying any velocity when it is falling down, then you are in confusion. That is the answer still T1 greater than T2 or it will be anything else? See, the first case, it is thrown from this point with a certain velocity u, it will reach to a certain height, okay, and retardation throughout the path is g plus some air resistance A0 I consider. Air resistance is considered as A0, producing some acceleration, retardation in the downward direction. Okay, so downward retardation will now not G, it is G plus something, that is G plus A0 because of the air resistance. So it will reach to a certain height. So what will be that height? I can calculate u square by 2g. So that maximum height reached will be u square by 2g. 2g means 2 into g plus a naught. Clear? So this is my first equation.
So could you use black?
Oh. Which one? This one. Eraser. h will be u square by 2 into g plus a naught. And in how much time the ascending is complete? T1 it is given. So final velocity will be 0, initial velocity will be u, minus retardation will be g plus a naught into time taken T1. So T1 we can also calculate. So that is u by g plus a naught. Okay, this is for the first part. Time taken is u by g plus a naught to reach to the top, and maximum height reached h equal to u square by 2 into g plus a naught. Now come to the second part of the problem. After reaching this point, body is falling down. Okay. So in how much time it will fall down? It is given T2. And from which height it is falling? Same. In time T2 it will reach to the ground. What is its initial velocity? Nothing provided, because initial velocity at the topmost point will be 0. So now the equation will become h equal to ut, but u for this part will be 0 plus half, it is falling with acceleration g minus a naught, because now the air resistance is upward. So initially if there is no air resistance, it will fall with g. Now it is falling with an acceleration less than g minus a naught into T2 square. So expression for h I can put. So it will be u square by 2 into g plus a naught equal to half g minus a naught into T2 square. Done? It is thrown from this point, it reached to a maximum height. In the first part, maximum height reached will be u square by 2 into total retardation, that is g plus a naught. Time taken is u by g plus a naught. Now from this point it is falling down again. So it will be covering a displacement h in time t2 with initial velocity 0 and acceleration changes to g minus a naught because of the air resistance. So we can calculate again. So from this we can write, this 2 will cancel, it is coming T2 square equal to u square by g plus a naught into g minus a naught. Okay. T2 square will be u square divided by g plus a naught by into g minus a naught. Now take a square of this equation. T square, T1 square equal to u square by, okay, divide this two. T1 square minus T1 square by T2 square. Divide these two equation. T1 square by T2 square. I square both first equation because I have to eliminate u. So what it's coming? T1 square by T2 square, it is coming g plus a naught by plus a naught by g minus a naught. কি আসছে না উল্টোটা আসছে g minus a naught by g plus a naught, it is coming. g minus a naught by g plus a naught. Okay, then from that you can conclude the answer. G plus a naught is always greater than g minus a naught. তো ডিভাইডটা একবার করেই দেখা যাক। So you will divide it once. So it is coming this one, u square will cancel. This term will be in the numerator and this term will be in the denominator. So 1 g plus a naught will cancel. So it will be g minus a naught by g plus a naught. So clearly it is seeing that this is less than 1. This one is less than 1 because g minus a naught is always less than g plus a naught. So from that you can argue that T1 is less than T2. T1 less than T2. Okay, so think that if you argue from the first logic that only retardation is more in the first case, so it will take longer time to ascend, then it is wrong, because the velocity that is provided during the time of ascent that matters. So don't try to solve this problem only with the concept of acceleration. Remember, there is some initial velocity provided and that can change the answer. Okay, question number 5. A balloon rises from rest with a constant acceleration g by 8 with a constant acceleration g by 8. Okay, a stone is released from it when a stone is released from it when it is at a height h above the ground and moving upward. The time taken by the stone to reach the ground is option A 4 root h by g, means 4 into root h by g. H by g is under root. 4 into root over h by g, Option B, 2 into root over h by g. Option C, root over of 2h by g. Root over of 2h by g. Option D, root over of h by g. E. 4 by 3. অপশান নেই তো। See, when the balloon is rising upward, so this is the situation. Balloon is rising upward by a height h. So at this point, balloon achieves some velocity. So what is that velocity that we can calculate? Initial velocity of the balloon is 0. Final velocity at this moment, let it be u1 for the balloon. Here u equal to 0 when it is moving up. Now it is moving up with a certain acceleration. What is that acceleration given? G by 8. This is the effective acceleration, G by 8. Because apart from gravity, some more acceleration is given such that the net acceleration G by 8 anymore? No, because it is now released from the balloon, means it is detached from the balloon. So with what acceleration the stone will fall? G. But there is an initial velocity of the stone in the upward direction, same as that of u1 because of the inertia. When the stone is dropped from the moving balloon, the velocity of the balloon is along with the stone, stays with the stone because of the inertia, but the acceleration is not staying with the stone, because since the bodies are detached, acceleration cannot transfer. Only thing that can be transferred is the velocity because of inertia. Clear? So due to inertia and due to that velocity, the stone has a tendency to move little bit up, and then again the stone will come down. Now we are not interested in that little bit coming up and down, because we want to calculate the displacement. Whatever be the stone moving up and down up to the ground, displacement will remain same, because for that part moving up and come here, there displacement will become 0. So only the initial point is the point of detachment, and the final point is the point when the stone is touching the ground. So displacement remain same. Now for the stone, you have to write the equation. I assign that all the quantities above this are positive, all the quantities below this are negative, like positive y-axis and negative y-axis. So in that respect, if I try to find the time taken by the stone to come to the ground, if that is t, then I will consider the equation s equal to ut plus half at square. So first, what is s? S is the displacement of the stone to reach to the ground. So when stone will reach to the ground, what will be its displacement? H, but that should be minus, because now you are measuring from the reference point of the stone. So this is the initial position of the stone, this is the final, and it is in the downward direction. So you have to put minus h for the displacement. Okay, you have to consider them as vectors. Now u1 is in which direction? u1t, u1 is upward, so simply write u1t. Acceleration of the stone is down, minus half gt square. Put the value of u1 here and solve for t. You can put the value of u1 at the last. That is also possible. First, from Sridhar Acharya's method, find expression for t and then put the value of u1. That is much more easier. So from this you can multiply both sides with 2. It will be minus 2h equal to 2u1 t minus gt square, which gives us gt square minus 2u1 t minus 2h equal to 0. gt square minus 2u1 t minus 2h equal to 0. Then apply Sridhar Acharya's formula. T equal to minus b plus minus root over of b square minus 4ac. 4 into a means g. 4g into c is 2h means 8gh. 8gh by 2a. Now obviously this minus sign will not work here because it will give you a negative time, so that is not the possible answer. So t will be only the positive value of this. Now you can simplify by putting these values. It can be written as u1 by g plus, from in this entire term 1 2 can be taken common, so it will be root over of u1 square by g square plus 2h by g. See the first term 2u1 by 2g, so it will be u1 by g. Next term, take 4 common first. It will be coming out as a 2 after square root, so this 2 and this 2 will cancel, so this term will be root over of u1 square plus 2gh by g. That g is taken inside the root by taking a square, so it will be u1 square by g square plus u2h by g, because there is 8. I have jumped 2 to 3 steps, and then put the value of u1. u1 is equation 1. Just put the value of equation 1 and simplify. See, so t will be u1 is this one divided by g. So root over of gh by 2 divided by g, it will be half into root over of h by g, half into root over of h by g, plus next term u1 square by g square. u1 square means this term will be gh by 4 divided by g square, gh by 4 divided by g square. So one g will cancel, so it will be h by 4g, h by 4g, because gh by 4 after squaring inside divided by g square. So one g will cancel, so it will be h by 4g plus the next term 2h by g. Okay, then simplify. কত আসছে এসছে 2h by g, 2 into root over of h by g. After simplification you will get, that is option B. Question number 10. The displacement x of a particle varies with time t as displacement x of a particle varies with time t as this is question number 10. I think it is also a mock paper question. X equal to some a e to the power minus alpha t plus b e to the power minus e to the power plus beta t, b e to the power beta t, where a, b, alpha and beta are positive constants, where a, b, alpha and beta are positive constants. The velocity of the particle will, option A, decrease with time, option B, be independent of alpha and beta, be independent of alpha and beta? Means will be independent of alpha and beta. Option C, drops to zero when alpha equal to beta. And option D, increases with time. Will increase with time. Increase with time. B. If you find the derivative of this equation, you will get the velocity v, instantaneous velocity. Is that independent of alpha beta? First calculate V, taking a derivative of this equation. V means dx dt, so it will be minus alpha a e to the power minus alpha t plus beta b e to the power beta t. Okay, now is it independent of alpha beta? No, so option B is not correct. If you put alpha equal to beta, is that become 0? No. Check, first term and second term are not equal if you put alpha equal to beta. So option C is also not correct. Now check this situation. If you put t is very large, if t is increasing, what will happen? This term e to the power minus alpha t will decrease and e to the power plus beta t will increase. Now exponential term, when t tends to infinity, this term tends to, and this term. So what is the correct answer? Option 4, because lower limit of this term when t tends to infinitely large is 0, because this term has a minimum value of 0, but this term has no barrier, it can rise up to any value. Okay, so the velocity with time will actually increase. Because e to the power minus alpha t cannot be less than 0, but there is no such barrier for e to the power plus beta t. E to the power plus beta t can rise up to any value, up to infinity. So the velocity will rise with time. So option D is correct. Okay, because this term goes faster than this first term, so always there is an increase in velocity with time. Question number 8. The velocity, the instantaneous velocity v of a particle moving along x-axis varies with position x as shown in the figure. Straight line. Velocity versus displacement graph, position graph is given a straight line intersected at point 0, 4 and 2, 0. The acceleration of the particle varies with position as. Acceleration of the particle varies with position as. Option A, a square equal to x plus 3. Option A, a square equal to x plus 3. Option B, a equal to 2x square plus 4. Option C, 2a equal to 3x plus 5. Option D, a equal to 4x minus 8.
Option B, last option.
How?
So it's time, so y is equal to mx plus c. So y is equal to mx plus c. So 4 is that's the time.
Slope of this equation, but it is v versus x. Its slope is not acceleration.
So the area of this triangle.
Area v into x. How that can be acceleration?
So half into the base into the height.
Half into base into height. It is
Area.
area. Area is acceleration. How? Can you prove? Means it is v dx. Is v dx acceleration? Then it is somehow matching. স্লোপটা তো এ বাই ভি নয়,
এটা গ্রাফের স্লোপ তো এই ভাই ভি আসবে।
কি করে? এটা তো ভি বাই এক্স, ডিভি ডি এক্স।
এইটা করলে তো এ ইকুয়াল টু ভি dx a by b equal to dv by dx. So v plus slope by dx.
তারপর তাতে এ ভার্সেস ভি এর রিলেশন বেরিয়ে যাবে। এই স্ট্রেট লাইনের ইকুয়েশনটা বার করো। ওই পয়েন্ট স্লোপ ফর্ম আছে না, মনে আছে? এর মধ্যে যদি দুটো পয়েন্ট থাকে, মনে করো x1 y1, মনে করো x2 y2, তাহলে এদের মধ্যে যদি স্ট্রেট লাইন হয়, স্ট্রেট লাইনের ইকুয়েশনটা কি হয়? y মাইনাস y1 বাই x মাইনাস x1 ইকুয়াল টু x1 মাইনাস y1 মাইনাস y2 by x1 minus x2. This is the equation of a straight line passing through 2 points x1 comma y1 and x2 comma y2. Okay, this is a general formula coming from the coordinate geometry's straight line portion. So from this we can find, see here y coordinate is v and x coordinate is x. So we have an equation between v versus x. So following this equation, if I put y equal to v minus y1, any point you can choose to be y1. Y1 is considered, this equation, this point is considered as x1 comma y1. This point is considered as x2 comma y2. Just now put the values. Y1, what is y1? 4 divided by x minus x1. So x minus, what is x1? 0 equal to y1 means 4 minus y2. Y2 is 0 by x1 minus x2. x1 is 0, x2 is 2. So from this we get the equation of the straight line v versus x. So it is coming v minus 4 by x equal to minus 2. This is 4 by minus 2. 4 by minus 2 means minus 2. So the equation will become v minus 4 equal to minus 2x, and then v equal to 4 minus 2x. V equal to 4 minus 2x. Okay, then what should we do? Just take a square of both side. It will be v square equal to 16 minus 2 ab term, 2 into 4 into 2x, that is 16x plus 4x square. Okay, I am taking a whole square of both side. So this term 4 square, that is 16, 2ab term minus 2ab means 2 into a is 4, b is 2x. So 2 into 4 into 2, that is 16 into x plus 4x square. Now I want to take a differentiation of both sides with respect to x. So it will be left side. What is its differentiation with respect to x? 2v dv dx. 2v dv dx. Its derivative will be 0. This term's derivative will be minus 16. And this term's derivative will be plus 8x. Now divide entire term by 2. Now what is v dv dx? Equal to divide by 2 means 4x minus 8. So this is the correct option. So first you have to find the relation between V and X by finding the equation of that straight line. Then after that you can differentiate the V with respect to X. It is better to use a squaring both side and after that do the differentiation. Otherwise you will get dV dx and then you have to multiply with V again. So I am squaring both side at this step and then differentiate, because V dV dx is another form of the acceleration. Okay. Okay, you can take a small break.
Can I simply
See, write down question number. This is from projectile motion and vector, mainly two-dimensional motions. Write down the topic, two-dimensional motions. Problems part 1. Question number 5. The component of vectors capital A equal to 2i cap plus 3j cap along the direction of vector B, along the direction of vector B equal to I cap plus j cap is option A 5 by root 2, option B 5 by root 2, 5 by root 2, again 5 by root 2, I cap plus j cap inside bracket. Option C 5 by 2, option D 5 by 2 into I cap plus j cap inside bracket. Check. 5 by root 2, 5 by root 2 into I cap plus j cap, 5 by 2, 5 by 2 into I cap plus j cap. 4 options are given. First things, the question, it is required the component, not the projections only. If the only projection is required, then it is a scalar part, then only the magnitude of the component has to be calculated. But since it is said that component has to be calculated, so a vector's component will be another vector. It cannot be a scalar. So you have to calculate not only the projection, you have to calculate the vector whose direction is along B vector. Clear? Option C. Vector A is given. It is 2i cap plus 3j cap. Vector B is given. It is I cap plus j cap. Now think of the situation. This is suppose vector A and this is vector B. So you have to find the component of A along B. So this part, okay. Now this part is called the A. If this angle is theta, then this is called A cos theta. So that A cos theta has to be calculated. So how to calculate A cos theta? We know that AB cos theta equal to simply A dot B. Okay, AB cos theta equal to A dot B. Then what is A cos theta? Then I divide this one by B. So it will be A dot B cap. So first we have to calculate A dot B cap to calculate the magnitude of this vector. Now what will be its direction? It is along B. So direction of unit vector of direction of B has to be multiplied with this magnitude. Okay. So our final answer will be A cos theta multiplied by B cap. One more B cap. So that is A dot B. First you have to calculate this and then you have to multiply the entire thing with B cap. Then it is your answer. Okay. Clear? Now what is A? This one I can write B cap. B cap will be I cap plus J cap by root 2, because vector B's magnitude will be root over of 1 square plus 1 square. So it will be root 2. So first calculate this one. So A dot B cap, it will be 2 plus 3 divided by root 2. Then write one more B cap, that is I cap plus J cap by root 2. So your answer will be 5 by 2 into I cap plus J cap. Okay. If it is asked that what is the projection only or the magnitude of the component, then your answer will be this one, that is 5 by root 2. So it will be 5 by 2 because there is another root 2. So that's why it is not 5 by root 2 into I cap plus J cap. It will be 5 by 2 into I cap plus J cap. So option D is correct. So whenever this is vector A, its projection on B will be given by A cos theta, that is the magnitude. Now here asked for component. Component means a vector's component can be a vector only. So you have to multiply this magnitude with the direct unit vector on in this particular direction of B. So direction of B's unit vector will be B cap. So I might multiply this projection with B cap to find that component. Okay. So if there are questions like this, if it is said that projection or magnitude of the component, then the answer will be a scalar. If it is said component only, then the answer must be a vector. But sometimes in the question they asked for component and they give only the scalar magnitude. So careful about the question what is given and then tick the correct answer.
Then we have to choose 5 by 2 or 5 by
5 by? If it is only projection, then it is 5 by root 2.
Sir, if it is in question it is given component and in option both 5 by 2 and 5 by 2.
No, if 5 by 2 is still there, then this is not a unit vector. Apart from the unit vector, remaining part is magnitude. So what is the unit vector of this one? This. So remaining part is the magnitude. 5 by root 2. The vector's magnitude in this case, the component vector's magnitude is 5 by root 2. Its direction unit vector is given by containing another root 2. So don't think that this is coming means its magnitude is 5 by 2. Its magnitude is still 5 by root 2. Because I cap plus J cap is not a unit vector. I cap plus J cap by root 2 is a unit vector. Okay. Then question number 11. So this part is very careful. If it is coming 5 by 2 I cap only, then you can say that I cap is a unit vector, so 5 by 2 is the magnitude. If it is coming 5 by 2 I cap plus j cap, then you cannot say 5 by 2 is the magnitude, because I cap plus j, I cap is a unit vector, separately j cap is a unit vector, but I cap plus j cap is not a unit vector because its magnitude is root 2. Now question number 11, if a vector 2 I cap plus 3 j cap plus 8 k cap is perpendicular to the vector, is perpendicular to the vector minus 4 I cap plus 4 j cap plus alpha k cap, then the value of alpha is, option A minus 1, option B half, option C minus half, option D plus 1. Just take a dot product of these two vector and result of the dot product should be 0. Then equate that dot product to 0 to find the value of alpha. Minus half. Dot product 0 means vectors are perpendicular to each other. Okay, now question number 16. A particle has initial velocity 3 I cap plus 4 j cap. A particle has initial velocity 3 I cap plus 4 j cap and has acceleration 0.4 I cap plus 0.3 j cap. 0.4 I cap plus 0.3 j cap. Its speed after 10 second is, option A 7 unit, option B 7 root 2 unit, option C 8.5 unit. Option D, 10 unit. Seven root 2. Seven. You have to use this equation in vector form, that is V equal to U plus AT. Okay, so this U is given how much? 3 I cap plus 4 J cap. This A is given 0.4 I cap plus 0.3 J cap. And this is given 10 second. So if you multiply 10, so this will be 4 I cap plus 3 J cap. So it will be 7 I cap plus 7 J cap. So the magnitude of V is the speed, that is root over of 7 square plus 7 square, 7 root 2 unit. Okay. Next question. Question number 18. The horizontal range and maximum height attained by a projectile are capital R and capital H respectively. Capital R and capital H respectively. The horizontal range and maximum velocity of a projectile, the horizontal range and maximum height attained by a projectile, are capital R and capital H respectively. If a constant horizontal acceleration g/4 is imparted to the projectile by the wind, if a constant horizontal acceleration g/4 is imparted to the projectile by the wind, then the range and maximum height will be option A, R plus H, comma H/2, option B, R plus H/2, 2H, option C, R plus 2H, comma H, option D, R plus H, comma H. Means how they are changed. We know that projectile motion is occurred only under gravity. Now here the motion is modified due to the presence of a horizontal acceleration imparted to the particle by wind. Then what will happen? Means what will be the modifications in range and maximum height? First tell me which between range and maximum height will be modified. Range will be only modified because that acceleration is along the horizontal direction. The extra acceleration is along horizontal direction. So it has no vertical component. So vertical motion is still under the gravity. So maximum height is a vertical direction. So vertical direction is totally unaffected due to this acceleration. Okay. Now this question comes in mind that if, okay fine, acceleration is along the horizontal direction, the extra acceleration provided by the wind is given is to the horizontal direction, so it will not affect the vertical motion. So we are arguing that H remain same and R will change. But there is one crucial point that can arise at this moment, that if the time of flight changes, then can the vertical height remain same? What you are arguing on the basis of the rectangular resolution, perpendicular resolution of the vector, that one part is independent of the other. Okay, fine. But I am asking that is, if the time of flight remain unchanged, then only you can consider that. But whether you check that time of flight is changed due to this acceleration or not, if there is a modification in the time of flight, then so you have to show that time of flight is not modified because of this acceleration in the horizontal direction. Okay, then only you can argue that only R will change and H will remain unchanged. Clear? Now, see, in a general projectile motion, the equation for R will be U square sine 2 theta, means 2 sine theta cos theta by G. Okay. Similarly, H it can be written as U square sine square theta by G, and time of flight is 2u sine theta by G. Sorry, this one is 2G. U square sine square theta by 2G and 2u sine theta by G. Now, what is u sine theta in a projectile motion? That is simply I can write y component of initial velocity, and similarly u cos theta is the x component of the initial velocity, so it can be written as u suffix x and u suffix y. Okay, so I write this equation in this form: 2ux uy divided by G. This one is uy square by 2G. This one is 2uy by G. Okay, I substitute first equation u square sine theta cos theta, so 2 is taken separately, and then u cos theta I put x, and another u sine theta I put uy. So it will become more compact form, ux uy. Okay, now see, the acceleration is in the extra acceleration is in the horizontal direction, so all the horizontal kinematical quantities will be modified, no vertical quantities are modified. Now check, is there any horizontal velocity? So it is not modified. Is there any horizontal velocity? It is not modified. So time of flight is not modified. Only the modification is here because there is the x component of the velocity, which will be modified due to this acceleration. Clear? So only modification is in r. So now the modified r we have to calculate. We consider the range r, now change to r prime. So if time of flight is there and it is entire time it is moving horizontally with some acceleration, so it will be simply calculated by s equal to ut plus half at square, because previously in general projectile we calculate only ut, that is u cos theta into t, because there is no horizontal acceleration. But in this problem there is horizontal acceleration, so the distance of the range can be calculated by using this formula ux into time of flight plus half into the new acceleration. What is the new acceleration given? G by 4 into t square. Just calculate. So it will be ux into t. What is ux into t? Previous range. Ux into t is the previous range. Check, ux means u cos theta, and and t means 2u sin theta by g. So it is the previous range, and calculate this entire quantity. It is the previous range means when there is no acceleration in the horizontal direction, it is that range plus something will now come due to this acceleration. So what will come as extra part? Put half into g by 4 into t square. T square means this one, that is 4uy square by g square. Put 4uy square by g square. Check what it gives. Uy square by this one. So the new range will be previous range plus another part that is equal to the maximum height. So the height remains same, only the range increases. The graph, if you draw the graph of this motion, this will look like this. Previously this is the projectile motion. Now it is increased. It is now increased by same amount. Height remains same but increased. A maximum height I draw here, but it may not be here, it may be here. So better to draw like this. Better to draw in this way. Previously like this. Now same height but here additional. Range will be increased. An increase in range by the same amount as that of the maximum height, r plus h. So this problem is conceptually more rich problem because it requires some idea of that acceleration is in the horizontal direction, extra acceleration. So it should not modify any quantity in the vertical direction. That comes from the concept of the resolution of the vector, because when we do the perpendicular resolution, because of this advantage that we can treat the axis independently. So any acceleration, if it is in x axis, it will not modify any physical quantity in y direction. So from that we first argue that h will not change, so there is no calculation for h. Okay. Second, we have to consider that time is not modified. Then we can calculate only the modified quantity along x-axis, that is the range only, and then put the values of range. Using this equation, s equal to ut plus half at square simply. Because normally in case of projectile, horizontal motion is motion with uniform velocity. So that's why we calculate only this term, not the other term. Now it is accelerated, so we have to calculate the extra term. Okay. Calculation of the problem is simple, but initial concept is more rich. Question number 24. A particle of mass m is projected with velocity u. A particle of mass m is projected with velocity u, making an angle 45 degree with horizontal. Making an angle 45 degree with horizontal. The magnitude of angular momentum of the projectile, the magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height. Particle is at its maximum height. That has to be calculated. We consider that the point about which angular momentum has to be taken, you can consider the axis, and axis is perpendicular to the plane of the projectile. Means if it is projectile, this plane is the direction of the axis, perpendicular to this. If it is xy plane, it is along z axis. Because if the axis is oblique, then again the complication will come to calculate the component and all those things. To calculate the magnitude of angular momentum. Option? Oh, আমি একটু মডিফাই করেছি, অপশন দিচ্ছি না কোশ্চেনটাকে। I am not giving any option because I have modified the question. Because there is something and I have changed to something. r cross p, angular momentum.
And here.
m u cube একটা আসবে। আরটা ক্যালকুলেট করেছো?
45 degree, 10 degree, 45. It's 45.
একটু পারপেন্ডিকুলার ডিস্টেন্সটা, এলটা তো এই দিকে, মানে ভেলোসিটিটা এইদিকে পয়েন্টে, মানে ইউ কস থিটা, আর এইখান থেকে এইটা ক্রস প্রোডাক্ট ভেতরের দিকে ক্রস প্রোডাক্ট করতে হবে। এবার ক্রস প্রোডাক্টে কম্পোনেন্ট নিলে হয়তো ইয়ে হয়ে যাবে, পারপেন্ডিকুলার ডিস্টেন্স চলে আসবে। এটা তো আর, তাহলে আর ক্রস এই দিকে এম দিয়ে মাল্টিপ্লাই করলে এটা হবে পি, তার এটা ভেক্টর হিসেবে নিলে আই ক্যাপ আসবে, আর এইটার একটা ভেক্টর আসবে, তার মধ্যে এইটা হচ্ছে তোমার এইচ আর এটা হচ্ছে r/2। এইটাকে লিখে ফেলতে হবে আর ইকুয়াল টু হচ্ছে r/2 আই ক্যাপ প্লাস এইচ জে ক্যাপ। এবার ক্রস প্রোডাক্ট করলে হয়ে যাবে। See, this is the motion. Okay. Now, this is your x-axis, this is your y-axis, this is the origin. Okay. Then, when the particle is at the topmost position, here, what is its velocity? u cos theta. Then what is its linear momentum at this point? mu cos theta, and direction I cap. So that is the linear momentum vector, which is denoted by p vector. Okay. Then from this point, this is the position vector up to this point of the particle when it is at the topmost position. So I can find this position vector as, this one is r/2, this one is h. So this position vector r equal to r/2 I cap plus h j cap. Okay. Then angular momentum L equal to r cross p. L will be equal to r cross p. So you can calculate these values. Theta is given 45 degree. So this p vector will become mu by √2 I cap. This one, calculate the range for this 45. What is the range? It is u square sin 2 theta by g. That means u square by g. Then by 2 is there. So range will, small r will become u square by 2g I cap plus, now h is for 45 degree u square sine square theta by 2g. What will be that? U square by 4g. J cap. Okay, so now put and do the cross product. I cap, J cap, K cap. In case of R, the terms are u square by 2g, u square by 4g. This term is 0, there is no k cap term. And for p vector, it is mu by root 2 0 0, because there is no other term except I cap in p vector. So only k cap's coefficient you have to calculate, no other is required, because all other term will be 0. So coefficient of k cap, if you calculate, then it will be this rule. First term will be 0, next term will be minus of this one, so it will be minus of this term into this term. It will be m u to the power 3 divided by 4 root 2 g. M u cube by 4 root 2 g k cap. So what is the magnitude? M u cube by 4 root 2 g. Because all other terms j cap, k cap, j cap, I cap, their coefficients will become 0. J cap and I cap's coefficient will be 0, only k cap's coefficient you have to calculate. So this is the answer, is m u to the power 3 by 4 root 2 g. This is the magnitude of angular momentum.